Let's look at page 9 of functions. Number 5, the diagram shows the graph of a function f from A to B, from set A to set B. Write down the set A. So set A is talking about the domain, and the domain in this case is going from this point to this point on the x-axis. That is going from -2 to 1, including -2 and 1. So we would write x is less than, or we're going to have -2 is less than or equal to x is less than or equal to 1. Let's do that for set B. Set B is the range, and so the range goes from this point to this point, which would be -1 to 2, considering the y's. So we would put y, and we would put -1 is less than or equal to y is less than or equal to 2. Okay, state whether f is a one-to-one function, giving a reason for your answer. So remember that the way you prove something as a function or a one-to-one or a many-to-one function is you do the vertical line test. So if we do the vertical line test, we're proving that it is one-to-one or many-to-one. How do we prove that it is only one-to-one and not many-to-one? Okay, because a one-to-one function means that it doesn't have many-to-one and it doesn't have one-to-many. If we also do the horizontal line test and we also only cut the function once each time, then that is proving that it is really just one-to-one. So how do you prove it's a one-to-one? You do vertical line test and you do horizontal line test, and on an exam question you're going to write down, oh, I did vertical line test and I cut the function only once in any one place. And for horizontal line test, I cut the function only once in any one place. You can't just say vertical line test, horizontal line test. You have to explain that you only cut the function 0 or 1 times whenever you drew the vertical line or the horizontal line. D, find if appropriate the values of f of 1, f of -1, f inverse. This is not f to the -1, it's f inverse of 1, f inverse of -1. Okay, and let me write something about what these mean. You have already looked at this a little bit on page 8, but just to review. So if we are going from A to B, then basically f parentheses equals something. The A's are here and the B's are here, right? And if you have f inverse, then you have the B's here and you have the A's here, right? Okay, hope that helps. So if I say f of 1, then I'm talking about the domain of 1, okay? So it would be like an x value, and the x value maps to a y value of 2. Number 2, f of -1. So this is, again, it's not f inverse, it's regular f. So I'm going to take a domain value of -1 and it maps to a y value of 0. I'm very hesitant to say x and y because there are expressions that say f inverse of x. And this x here is actually not the normal x you're thinking of, because the normal way the function is drawn, this actually becomes y. Okay, and so that's why I'm trying to put it in terms of a and b so that you don't get confused by the fact that there's an x here. This is still talking about the set B. Okay, and we're going to see why they sometimes write f inverse of x in a minute. Okay, all right, so f inverse of 1, we're talking about something from the set B, which would be the y-axis value, and we'll see what x value it maps to. It maps to an x value of 0, right? Because this point here is 0, 1, so it's equal to 0. F inverse of -1. F inverse of -1 is talking about the y-axis value -1, which maps to this point here. This point is -2, -1, right? So this maps to an x value of -2. Okay. This next question is purely a text question. There's no graph that goes along with it. The circumference of a circle is a function of its radius. C of r equals 2 pi r. Find the C inverse of 8 and interpret the meaning of this value in context. Okay, so remember that here we have the input of r and we have the output of the circumference. So if we have an inverse function c, the output becomes the input. So this is actually a circumference, and out should come the radius. Okay, so the meaning of c inverse of 8 is what is the radius of a circle with a circumference of 8. Okay, so that's what c inverse of 8 means. Okay, because normally what goes into parentheses for the function c is the radius, but if you do c inverse, the output goes in the parentheses, which in this case is the circumference, right? And then you get the input back, which is the r. Okay, and number 2, draw the inverse function of each of the following functions. And when I say each of the following functions, I mean these two functions. Okay, so how do you draw an inverse function? This is, once you have the procedure, it's quite easy to do. It's also quite easy to forget. There's a lot of people in math analysis who, they know this on the day that they learn it, but then like 3 months later when they're asked, they totally forget. Okay, so let's look at how you do this. Basically what you do is, and let's take a look at some of these maps that we did before. When we do an inverse function map, is this the inverse function page? Yeah, this is the inverse function page. Okay, so when we do inverse functions, remember that we just reverse all of the arrows, right? So we're going backwards from the right side to the left side. We go from B to A. Okay, so basically what you're doing is you're taking all the ordered pairs, like the ordered pairs are 1, 1, 2, 0, 3, 5, negative 3, 2, right? Those are the 4 ordered pairs. What you're doing is you're reversing it, right? The input becomes the output becomes the input. So the 1 maps to 1, 0 maps to 3, 5 maps to 2, and 2 maps to negative 3. So the original ordered pair 2 maps to 5 becomes 5 maps to 2, right? So do you see how they just basically inverted the 2 positions? So that's how you make graphs of inverse functions. You reverse the positions. So I'm going to take 2 specific positions on this, very important positions because of the endpoints, and I'm going to write them in their original coordinate form, which is 6, 3 and negative 6, 0. And for those of you who have trouble distinguishing between the horizontal and vertical coordinate and which comes first, which I know you do because I just did the oral exam for you on lines, you're going to have a lot of trouble with this. So try to get that straight. Normally, the horizontal comes first and the vertical comes last, okay? Now what we're going to do is we're going to make our new function, which is the inverse function. And the inverse function is going to invert these two and replot it. So 6, 3 is going to become 3, 6. And negative 6, 0 is going to become 0, negative 6. And you're going to plot those points. So 0, negative 6 is here. And 3, 6 is here. Here's the line connecting them. And do you notice that the point of intersection of the 2 lines, the function and its inverse function, cross at a special point, 2, 2, because they cross at points where both the x and the y are equal to each other. Okay, basically the function maps the number to itself. The inverse function also would map the number to itself, so it makes sense, right? Okay, and so now normally when you try to find the inverse function values, you look on the y-axis and then you see where it intersects the function, then you drop down and look at the x value to see what the output of the inverse function would be. Now what you can do is you could do the regular thing of looking for it on the horizontal axis and going up and then seeing what the y value is. Okay, so if you're using the regular function to find inverse function values, you start with the y-axis. If you're using the inverse function to find the original x values from y values, then you just use the x axis. Okay. In order to not get confused, you could maybe like get used to one method. So you could just use the regular function to figure out the inverse function values. And when they ask you to draw the inverse function, just use the rules that I just told you to draw it. But otherwise, just use the original function for everything. Okay, but figure out your own way. Let's do this other drawing here. We're going to use the exact same technique. We're going to look at special points, especially endpoints. So there's -4, 0, and here's another endpoint. It's 10, 4. And I think this is also special because it crosses the y-axis. This one is 0, 2, right? Now what we're going to do is we're going to reverse them all. So it gives us 0, -4, 2, 0, and 4, 10. And we're going to plot these 3 points in order to see what the inverse function should be. So for example, 2, 0 would be here. 0, -4 would be here. And 4, 10 would be here. And now what I'm going to do is I'm going to try to draw a nice curve through these, and this would be the inverse function. Okay, so that's the inverse function of the function drawn here. And you can see, once again, that it's supposed to cross like at a xy coordinate pair, which has the x and the y coordinate the same. And it looks like it's about 3, 3, right? My drawing isn't that good, so it didn't exactly cross at the at the exact right point, but it's pretty close. Okay. All right, so that's it for 2C. Now let's go to the next problem, which is the last problem in the unit. Consider f of x equals -2.5x plus 5 for the domain 0 to 3. And it says, draw the graph of f on a pair of axes. Use the same scale on both axes. So I've provided a grid for you here. And now what I'm going to do is I'm going to graph this line. Let me show you how to use the calculator to figure out how to do that. I think that it's the easiest way. So remember, when you want to graph something, don't go to the graph and try to copy the graph, because the graph here on the calculator is not that detailed that you can actually see that. So what we're going to do is we're going to use the table. So we put the function that they gave us here, -2.5x plus 5, and then we're going to see the table, and then we're just going to pick out certain values on the table and plot them. Okay, so for example, 0, 5. Let's plot 0, 5. Let's use blue. 0, 5. And 2, 0. And 4, -5. Okay, so those are enough points. It's a line, right? So I don't need to plot, more than 2 or 3 points. Now what I'm going to do is I'm going to connect a line through them. I'm just going to change the color of my. So I'm just going to connect the points. There's my line. If I want to make it go up, I can also. Let's see. Okay, that's pretty good. So I've drawn my function f on the graph. And then part B says point A lies on the graph of f and has coordinates 3, b. Find the value of b. So 3, b, that would be this point here, right? I could also find it with the table, right? 3, b means the x is 3. What's the y? So it would be -2.5, right? So my y value is going to be -2.5. And you can see that I actually put the green dot in the wrong place, right? It should be more like here. Okay, so really important to look at the table to see the real value. So b is equal to negative 2.5 according to the calculator. Draw the graph of f inverse on the same set of axes used in part A. Okay, so now what we're going to do is we're going to take the original coordinates and we're going to write down three important coordinates. The three important coordinates are 0, 5, 2, 0, and 4, negative 5. And we're going to invert them. So it's going to become 5, 0, and 0, 2, and negative 5, 4. Let's plot those 3 points. So 5, 0, and 0, 2, and negative 5, 4. Okay, and then let's draw a line that goes through those 3. Okay, and there's my green inverse function. And do you see how they cross at roughly 1.5, 1.5? So they cross at a point where the x and the y coordinates are equal to each other. So makes sense. Draw the graph of f inverse. Okay, we did that. Find the coordinates of the point that lies on the graph of f inverse and on the line y equals x. About how this yellow point has the x coordinate and the y coordinate the same, and that's the intersection of these two functions, and how that's an interesting point. They're now asking us for the point where the green function crosses the line y equals x. What is the line y equals x? It's the line where all the x coordinates and y coordinates are equal to each other. So basically what that means is, it means the diagonal line that goes like 45 degrees up into the first quadrant like that, right? So so that is about 1.5, 1.5. How can we figure out exactly what it is? So let's look at the table again, because the table is where we can get all of our exact coordinate values. And when we find out, how can we figure out this yellow point? The easiest way to find the yellow point is to look at the table and try to find an XY pair where there's a match. And I don't see any, right? Like, where do I get really close? Let's see. My guess is around 1.5, 1.5, right? So I should see it between these two, and that's where it would be, but I don't see it. So what I'm going to do now is I'm going to change the increment step size to 0.1 instead of 1, so that maybe I can see exactly where they cross. So I changed it to 0.1. And now I can see that 1.5 was a good guess, but it's not exactly right. Look, it's 1.5, 1.4, 1.5. So I think what I need to do is I move my cursor closest to where I think it's going to cross, or where it's going to be matching, and now I'm going to increase the step size. I'm going to increase the step size to I'm going to decrease the step size to 0.01. Now, is there a match here? I get really close. Look at this. I get really close here. So what I'm going to do now is I'm going to change the step size to 0.001. Four, 2, 9, 4, 3, 1.43. The closest point, the closest that I see here is the 1.4, around 1.43, right? 1.43, 1.42, 1.429, okay? I think what I'm going to say is 1.43, okay? So I would say 1.43, 1.43. How could you use the calculator to find the exact value? What you would do is you would say, okay, I'm going to I'm going to say, okay, where does this blue line cross the red line? And the red line is y equals x, right? And then I'm just going to do a graph. And then it's going to draw the blue line and the red line. By coincidence, on the graphing calculator, it's also a blue-red line and a red line. Okay. And then I'm going to do second calc intersect. Number 5. And then I hit enter 3 times. And 1.43, right? Okay. So either method is fine. You could use the table and just change the increment of the step size, or you could just put in the function y equals x and then do second calc intersect. Second calc intersect is faster, isn't it? Okay, and just to tell you how to get your table back to normal, after you've changed the increments to step size to something so small, you could do second table set and then change your table start to 0 and change your delta table also to, not to 0, to 1. Okay, and then you're back to normal. All right, find the coordinates of the point. We already did that. Now what we're going to do is we're going to write down the domain and range for each one. So the blue function has a domain of 0, 0 to 3. Oh, look what I did there. I actually made it too long, didn't I? This blue line only goes from 0 to 3. So it goes from here to here. So the part that goes beyond that, ignore that. Okay, and the green line should have similar endpoints. It should go between here and where's the other one? It would be the opposite of 3 comma something, so it would be about here. Okay, so I made my lines too long. All right, so the domain for the blue function is from 0 to 3. The range of the green function is also from 0 to 3 because it's the opposite, right? So I'm going to put 0 less than or equal to y is less than or equal to 3 because since the x coordinates and y coordinates invert, it makes sense that the domain limits 0 and 3 for the function are the range limits for the inverse function. And you can see that if you look at, like for example, the blue function goes from 0 to 3 on the x-axis, right? And the green function goes from 0 to 3 on the y-axis. Okay? All right, so what about the blue function range? The blue function range goes from 0, comma 5 to 3, comma something. Let's see exactly 3, comma what? 3, comma negative 2.5. So this point here is 3, comma negative 2.5. So this point here is going to be the opposite. It's going to be negative 2.5, comma 3. Okay, and so let's go back to the range of the blue function again. The range of the blue function would be the y coordinate here to the y coordinate here. So it would be negative 2.5, I'm sorry, negative 2.5 less than or equal to y is less than or equal to 5, right? And then for the green function, the domain or the x coordinate ranges from negative 2 to 5, right? I'm sorry, negative 2.5 to 5. Okay, so finding domain and range of the green and red function, ignore the fact that I went too far. I went too far, right? I shouldn't have drawn this part and I shouldn't have drawn this part because it told me that the domain of the blue function was between 0 and 3. I went too far. And then because of that, I went too far with the green function too. So ignore that, those parts that I went too far, and consider the endpoints, these circled green and blue points. And if you consider that, then the domain and ranges would be as they are written here. And notice there's a nice symmetry here where the negative 2.5 here is the same as that negative 2.5. The 5 here is the same as this 5. The 3 here is the same as this 3. The 0 here is the same as this 0. But the domain is always x values and the range is always y values. Okay? So that's it.